What if your daily creatine dose was actually losing 30% of its power? This is not about which brand you buy or how consistently you take it. The real problem is something so basic that you would never guess it. And the fix is incredibly simple once you understand what is actually happening. We are not talking about drinking more water to feel less thirsty. We are talking about deep cellular hydration that determines if creatine works. Creatine is not just a powder that builds muscle during your training sessions. Scientists classify creatine as a cellular osmolyte with a very specific job. Its primary job is to pull water directly into your muscle cells. That swelling you sometimes feel is not a side effect at all. That swelling is actually the core mechanism behind muscle protection and growth. The more creatine stored inside your cells, the more hydrated those cells become. A landmark study confirmed creatine increases cellular hydration inside muscle tissue directly. Researchers discovered the hydration effect was tied to stopping protein breakdown. Creatine protects the muscle you already have by keeping cells properly hydrated. That swollen, hydrated state signals your body to stay in anabolic growth mode. This distinction completely changes how you should think about creatine supplementation. Most people chase more creatine when they need better conditions for it. Here is exactly where most people fall apart and make a huge mistake. They unknowingly cost themselves 30% of their potential results every day. Creatine cannot float through your cell membrane on its own at all. It relies entirely on a very specific transporter protein to enter cells. That transporter is called SLC6A8, and it controls every creatine molecule you absorb. The part nobody ever tells you involves sodium and this transporter protein. This transporter literally requires sodium to pull creatine into your muscle cells. It directly couples creatine uptake to the inward movement of sodium ions. The sodium-potassium pump constantly pushes sodium out of the cell membrane. This maintains higher sodium concentration outside than inside your muscle cells. That concentration difference creates the powerful pulling force for creatine uptake. A stronger sodium gradient creates a stronger pull for creatine absorption. If your sodium levels are off, the transporter simply does not do its job. Your creatine ends up floating around in your bloodstream going nowhere useful. It never actually makes it into the muscle where it truly belongs. Think of it like a package delivered to your door that sits outside. That package just sits in the rain and never actually gets inside. That is exactly what happens when you take creatine in a low sodium state. When you are dehydrated, your body activates a system called AMPK immediately. AMPK functions as your internal emergency energy triage mechanism for survival. This system sends a signal telling your body that survival mode is on. It shuts down all non-essential processes to conserve energy for survival immediately. One of the first things deprioritized in that survival state is creatine uptake. Your body essentially says, creatine can wait right now for survival priorities. Being dehydrated while taking creatine means your body actively blocks absorption pathways. On top of that, dehydration drops your plasma volume significantly right away. Less plasma volume means significantly less blood flowing to your working muscles. Less blood flow means less creatine reaches the transporter before absorption happens. So you are losing creatine at two completely different points in the process. First in delivery and then a second time at the absorption stage. Proper hydration drives up blood flow and increases nutrient transport to muscles. It creates the exact intramuscular conditions that creatine needs to enter cells. But hydration alone is still not the complete answer for maximum results. This is the layer where most people keep missing everything important entirely. Many people unknowingly surrender a significant portion of creatine's potential results. They ignore the carbohydrate and electrolyte timing context completely in their routine. There is a carbohydrate and insulin connection that changes creatine retention dramatically. Every gram of glycogen stored in muscle tissue holds 3 to 4 grams water. If your glycogen stores are low, your body holds significantly less water. And creatine's osmotic pulling effect gets seriously weakened without enough glycogen. This is why pairing creatine with electrolytes and carbohydrates is actually strategic. A classic study gave subjects 5 grams of creatine alone every single day. Another group took 5 grams of creatine with 93 grams of carbohydrates. The group with carbohydrates showed significantly higher creatine retention overall. But the reason behind this result is far more interesting than you think. It is not simply because carbohydrates help absorption through insulin alone. There are actually 3 completely separate insulin mechanisms at work here. Each one builds directly on the previous one for maximum creatine absorption. These 3 mechanisms do not work alone, but stack and compound together. They dramatically increase total creatine absorption with every single dose you take. The first mechanism is insulin increasing sodium-potassium pump activity in muscles. When insulin spikes, the pump works harder and your sodium gradient strengthens. Creatine gets pulled into the cell more aggressively with every single dose. This is a direct amplification of the transporter's driving force for absorption. More creatine enters your muscle with every dose you actually take. The second mechanism is insulin-triggering vasodilation in your skeletal muscle tissue. This happens through the powerful internal release of nitric oxide molecules. More blood flow means more creatine reaching the muscle membrane for absorption. More of the transporter gets directly exposed to creatine in the bloodstream. Think of it like widening a highway and raising the speed limit simultaneously. This creates maximum throughput for creatine entering your muscle cells efficiently. The third mechanism ties everything together in a way most people never hear. We already know creatine enters the cell and pulls water inside it. That causes the cell to swell and trigger anabolic signaling for growth. Insulin enhances that entire process by activating mTOR inside your muscle cells. It reduces muscle protein breakdown while powerfully driving up protein synthesis. When the cell swells through this entire insulin-enhanced process, something amazing happens. It then holds on to even more creatine deep inside itself permanently. This is called a positive feedback loop, where more insulin creates more swelling. More swelling creates even greater creatine retention inside your muscle cells. The incredible part is you do not need a large amount of carbohydrates. Research suggests that 10 to 30 grams of carbohydrates is more than enough. This small amount activates the entire powerful cascade for creatine absorption. Creatine taken with a mixed meal containing protein, carbohydrates, and electrolytes works best. This represents the ideal and most effective absorption scenario currently available. Creatine works best not when you take more of it each day. It works best when you finally create the right conditions around it. The worst thing you can do is take creatine right after sweating heavily. This is when you are completely depleted and dehydrated from exercise. This is the exact recipe for bloating and poor absorption results. So many people conclude creatine is not working because of this mistake. Instead, always rehydrate first with water and electrolytes before taking creatine. Take your creatine alongside that electrolyte drink for maximum absorption results, or take it very shortly after while your body is fully replenished. If possible, pair creatine with a real meal that includes some carbohydrates. Add a generous pinch of natural sodium to that meal for best results. We need to flip this completely because creatine enhances your cellular hydration too. When creatine enters the cell along with sodium, the osmotic load increases. This creates more dissolved particles inside the cell than outside it. Water gets naturally drawn inward to restore perfect balance in the cell. That swelling is not the puffy water retention most people actually fear. It is deep intracellular fullness inside your muscle cells that matters. Your cells are self-regulating their hydration status continuously every single moment. And creatine is one of the most powerful drivers behind that process. Once swollen and hydrated, that cell enters a fully protective anti-catabolic mode. It holds on to creatine dramatically longer when in this protected state. When the cell signals it is in growth mode, everything inside gets retained. Water, creatine, and amino acids all get trapped inside the muscle cell. The hydration story becomes more powerful when we bring glycogen into it. We also need to bring the GLUT4 transporter fully into this conversation. GLUT4 is the protein transporter responsible for pulling glucose into muscle cells. It pulls glucose out of your bloodstream and into muscles for storage. When this transporter functions efficiently, your muscles absorb carbohydrates much better. They store more glycogen and hold far more water inside them. A remarkable study had subjects immobilize one leg in a cast completely. They did this for 2 full weeks to deliberately induce muscle atrophy. After immobilization, half the subjects received creatine during their rehab program. The other half received only a placebo during their 10-week rehab. During immobilization, GLUT4 content dropped by around 20% significantly. This meant muscles were struggling to absorb any glucose effectively at all. In the creatine group, GLUT4 actually increased by 9% during immobilization. This means creatine actively protected the glucose transporter during complete disuse. After 3 weeks of rehab, the creatine group had amazing results. Their GLUT4 levels were a full 40% above their original baseline. Their muscle glycogen was dramatically higher than the placebo group completely. They experienced a supercompensation response that the placebo group missed entirely. The creatine group did not just recover from the muscle atrophy. They rebuilt muscle at a rate the placebo group simply could not match. Remember that every gram of muscle glycogen holds 3 to 4 grams water. Creatine massively increases that glycogen by increasing GLUT4 transporter function. It boosts glycogen storage simultaneously for maximum water retention inside muscles. Creatine indirectly increases the total amount of water inside your muscle tissue. You get the direct hydration from the osmotic creatine effect immediately. You also get a separate glycogen-based hydration effect compounding on top. These two mechanisms stack on top of each other for maximum effect. They create a double hydration effect that amplifies everything creatine does. No other single supplement creates this layered compounding hydration effect naturally. Creatine might even help you metabolize carbohydrates more efficiently over time. It does this by improving the sensitivity of your GLUT4 transporter. Creatine already does remarkable things for cellular hydration, as we discussed. But now we get to the compound that multiplies all of these effects. Most people dismissed this compound for years with unfair prejudice. They only associated it with cheap old energy drinks and nothing more. The energy drink industry accidentally stumbled onto a powerful compound. They ended up putting it next to sugar and caffeine, unfortunately. In reality, this compound is one of the most powerful amino acids. It is well researched and found throughout the entire human body. We are talking about taurine, which exists in massive concentrations everywhere. It is found in your brain, your heart, and your skeletal muscle. Taurine is also an osmolyte with a very specific cellular job. Its core job is to regulate and stabilize fluid balance inside your cells. Creatine is the force pulling water into the cell aggressively. Taurine is the internal system that manages everything once water enters. Without taurine to regulate the influx, cells can become oversaturated quickly. They lose the electrochemical ionic balance they need to function properly. Taurine prevents this from happening and maintains cellular stability perfectly. That is precisely what makes it so deeply synergistic with creatine. Taurine also plays a critical role in calcium handling inside muscle cells. It directly affects the quality of muscle contractions during exercise. It improves calcium sensitivity for more efficient muscle contraction cycles. You get more efficient and effective muscle contraction and relaxation every rep. You get the raw ATP energy from creatine during your workouts. Taurine ensures the actual motor inside your muscle is working correctly, and then taurine directly affects the mitochondria inside your muscle cells. It does this by buffering against oxidative stress during intense exercise. During intense training, reactive oxygen species accumulate and cause damage. These reactive species directly impair ATP synthesis inside your muscle cells. They make creatine far less effective inside the cells over time. Taurine buffers against that oxidative stress and protects the cellular environment. It protects the precise environment in which creatine is doing its work. The mitochondrial protection from taurine ensures continuous energy production. Your cells can keep producing energy at the highest level possible. Creatine generates the energy, and taurine neutralizes the metabolic exhaust perfectly. Taurine protects the environment where creatine does all its important work. And here is something crucial that most people do not understand. Taurine has its own transporter called SLC6A6, which is completely separate. This is completely separate from creatine's SLC6A8 transporter for entry. They use completely different entry points into the muscle cell entirely. This means they can absolutely be taken together without any competition. They do not interfere with one another at the cellular level. Once they are both inside the cell, they work in powerful synergy. A true ergogenic stack is built on real cellular mechanisms, not marketing. This combination genuinely qualifies as a scientifically backed synergistic stack. Many people take taurine specifically to prevent muscle cramping during exercise. It regulates the electrolyte balance deep inside muscle cells efficiently. Together, creatine and taurine address the full spectrum of cellular hydration. Neither one can achieve this complete spectrum of hydration alone. When you combine creatine, taurine, and electrolytes together, something amazing happens. You are building what could be called the ultimate cellular hydration trifecta. Sodium powers the creatine transporter to pull creatine into your muscles. Creatine pulls water in and provides the energy for powerful contractions. Taurine stabilizes the hydration and ensures contractions remain efficient always. Then the electrolytes maintain all the necessary gradients for optimal function. Everything works together in a simple, synergistic, and powerful physiological system. This entire stack is backed by real science and documented research studies. Every component inside it plays a documented and clearly defined role. This is not speculation or broscience, but genuine physiological mechanisms. Now let us talk about the practical application of all this science. The timing of your creatine dose matters more than you might think. Taking creatine first thing in the morning on an empty stomach is suboptimal. Your sodium levels are often lowest after a night of sleep. Your hydration status is also lower after hours without water intake. This creates poor conditions for the SLC6A8 transporter to function properly. Instead, consider taking creatine with your first meal of the day. Your first meal typically contains some sodium and carbohydrates naturally. This provides the insulin spike and sodium gradient for optimal absorption. If you train in the morning, consider taking creatine post-workout instead. Post-workout, your muscles are primed for nutrient uptake and absorption. Your blood flow is elevated and your cells are ready for nutrients. This is an ideal window for creatine absorption into muscle cells. Always ensure you are well hydrated before taking your creatine dose. Drink at least 16 to 20 ounces of water beforehand. Add a pinch of salt to your water or pre-workout meal. This simple step ensures your sodium levels support the creatine transporter. If you are using a creatine powder mix, it with a carbohydrate drink. A sports drink or fruit juice provides the carbohydrates for insulin release. This small change can dramatically improve your creatine retention over time. Consider adding 3 to 5 grams of taurine to your creatine stack. This combination addresses both hydration and contraction quality simultaneously. The research on taurine and creatine synergy is compelling and well documented. Do not overlook the importance of overall daily water intake either. Your total daily water consumption affects your cellular hydration status significantly. Aim for at least half your body weight in ounces of water. This ensures your cells remain hydrated throughout the entire day. Spread your water intake evenly throughout the day for best results. Do not chug large amounts of water all at once. Your body can only absorb so much water at a given time. Consistent hydration throughout the day maintains optimal cellular conditions always. Remember that caffeine can have a mild diuretic effect on your body. If you consume caffeine, consider increasing your water intake accordingly. But do not avoid caffeine entirely if you enjoy it moderately. The diuretic effect is generally mild and easily offset with more water. The key takeaway is that creatine absorption depends on cellular conditions. Your cells need adequate sodium, water, and insulin for optimal uptake. Carbohydrates and taurine enhance these conditions for maximum creatine retention. This is not complicated, but it requires attention to the details. Most people fail because they ignore these simple but crucial factors. They take creatine haphazardly without considering the cellular environment at all. But now you understand the science behind proper creatine supplementation completely. You know about the sodium transporter and the importance of hydration. You understand the 3 insulin mechanisms that enhance creatine absorption. You know about glycogen storage and the GLUT4 transporter connection. You understand how taurine synergizes with creatine for complete cellular hydration. You have the knowledge to make every gram of creatine count. Stop wasting your creatine by taking it in poor conditions. Start implementing these strategies to unlock your creatine's full potential. Your muscles will thank you with better performance and growth. The science is clear and the application is simple and effective. Here is what nobody talks about with creatine supplementation at all. The real secret is not taking more creatine, but creating better conditions. Your creatine will work 5 times better when you do this. Now go ahead and apply this knowledge to your daily routine. Your results will improve dramatically once you optimize these simple factors. This is how you truly maximize the benefits of creatine supplementation. Stay consistent with these strategies and watch your progress accelerate. The difference between average results and exceptional results is in the details. You now have the details that most people completely overlook every day. Use this knowledge to transform your creatine results starting right now. This is the science-based approach that actually delivers real results. Forget the marketing hype and focus on what truly matters instead. Your cells are waiting for the right conditions to absorb creatine. Give them what they need and watch your performance soar higher. The ultimate cellular hydration trifecta is now yours to implement immediately. Sodium powers the transporter. Creatine pulls water in for fullness. Taurine stabilizes everything and maintains optimal cellular function throughout. This is the complete system for maximizing creatine absorption and results. Most people get this completely wrong, but now you know better. You have the knowledge to separate yourself from the average user. Your creatine will work better than it ever has before starting today. This is not speculation, but proven science you can trust completely. Now take action and make these changes to your supplementation routine. Your future results will reflect the quality of your current choices. Choose to optimize your creatine intake with these science-backed strategies. The results will speak for themselves once you implement these principles. This is the end of wasting creatine and the beginning of real results.